Hey guys, in this video we're going to learn how to use the midpoint and distance formula to determine the lengths, the midpoint, and the ratio of segments. The Pythagorean Theorem is something that we use to find the length of a side of a right triangle. So if we look at our diagram, we have a right triangle based on that right angle right there. And so we have three parts of our right triangle. We have our first leg, which is going to be our A, our second leg, which is our B, and our hypotenuse, which is across the right angle. So when we talk about across, we pass through the triangle, and that side across from the right angle is the hypotenuse, C. So to find the length of any side of a right triangle, as long as you have two sides or two lengths given to you, you can use the Pythagorean Theorem. And that states c squared equals a squared plus b squared. In example 1, we're going to use lengths of segments when we graph them diagonally. So finding the length of segment RT, where we know that R is -1, 0, and T is 4, 2. So on our coordinate plane, we're going to graph R, so we're going to go over 1 to the negative side, and don't go up or down. That's R. So then T is at 4, 2, so at the origin we're going to go over 4 in the positive direction, 1, 2, 3, 4, and then up 2, and there's T. So then we can actually use the Pythagorean Theorem to figure out the distance between these 2 points. But the thing is, we have to create a right triangle. So here is our segment, and to create a right triangle we're going to go to the right from R and up to T. So we draw an imaginary line, or what would be a leg of the right triangle, to the right, right until we get the same length as T, and then we go up to it. So here's our right triangle, and looking at the distance of the two legs that we drew, so this leg is 1, 2, 3, 4, 5, and the height is 2. So we have our A, B, and C in our right triangle. I'm sorry, our A and our B in our right triangle, but we got to figure out what our C is. So we have c squared equals a squared plus b squared, which is our Pythagorean theorem, and substitute what we know. So c squared represents what our T is. 5 squared is our A, or one of the legs. B squared is 2 squared. So simplifying that further, c squared is equal to 25 plus 4. Okay. And then c squared is equal to 29. And in order for us to get c, to get rid of that squared, we're going to take the square root of both sides. And c, or the length of RT, is equal to root 29. We can also find the length of segments using the distance formula. So the distance formula can help us use the coordinates of 2 points, and that'll help us determine the length between those 2 points. So let's say we have 2 points T and Q, where the coordinates are -4 and 1, and Q is 4 and 3. So if these are the 2 sets of coordinates that we have to find the distance between, well, for T, those coordinates are x sub 1 and y sub 1. Q would be x sub 2, y sub 2. So then the distance formula is a version of the Pythagorean theorem, states that d, which is distance or length, equals the square root of the quantity of x sub 2 minus x sub 1 squared plus the quantity of y sub 2 minus y sub 1 squared. So then, being careful when we actually apply the distance formula, we just substitute in your x sub 2's, your y sub 2's, your x sub 1's, and your y sub 1's in the appropriate spot. So x sub 2's would go there, your x sub 1 would go right next to it, y sub 2, x sub 1. And we're going to show you actually how to apply it in an example. In the second example, we're going to apply the distance formula. We have to find the distance between 2, -1 and 5, 3. So since we're trying to find the distance between these 2 points, let's write down the distance formula. Perfect. Okay. So after we write down the distance formula, so that we don't get confused, we have something to reference to, Let's now label our coordinates. Okay, so we carefully label each coordinate, x sub 1, y sub 1. So the little sub 1s represent point 1, and then we have x sub 2, y sub 2. Okay, so then using the distance formula, all we have to do is substitute in our values into our formula here. So we have d equals the square root of, in parentheses, 5 minus 2 quantity squared plus 3 minus negative 1 quantity squared. So then right away, the minus and negative 1, that would turn into a plus sign. So then we can simplify the formula further. So we have d equals the square root of 3 squared plus 4 squared. Simplifying further, we get 9 plus 16. The distance is equal to root 25, so the square root of 25 is a perfect square, or the 25 is a perfect square. So the distance between those 2 points is 5 units. Okay, so then we have to draw a diagram to confirm. We're going to use the Pythagorean Theorem just to double check that, 1, that the distance is actually equal to 5, and 2, that the distance formula is a component of the Pythagorean Theorem. So then if we plot those 2 points on our coordinate plane, we have 2, negative 1, 5, 3. So then we're going to draw a right triangle using this segment as our hypotenuse. Okay, so then here's our right angle. So then we know the length of either leg. We have 4 and we have 3. And then we're trying to figure out what that c squared is. So using the Pythagorean Theorem, we substitute our values for a and b. So we have c squared equals 3 squared plus 4 squared. C squared equals 9 plus 16. Simplifying further, 9 plus 16 is 25. And to undo a square, we have to take the square root of both sides. So we have c equals 5. So in fact, the Pythagorean Theorem does work along with the distance formula, because you get the same distance of 5 for the distance between these 2 points at 2, negative 1 and 5, 3. The next formula we're going to learn today is called the midpoint formula. Now the midpoint formula helps us determine where the middle point of 2 points are. So if we have one point, another point, we draw a segment in between. Okay? So our 2 points, just like in the distance formula, we have our x sub 1, y sub 1, and then our second point, x sub 2, y sub 2. So what this does is this formula is going to tell us what the coordinates of the exact middle between these 2 points. So somewhere around here. Okay? So that circle that we just highlighted in yellow, those coordinates would be our x sub m, m being our midpoint. So the x coordinate of the midpoint, comma, our y coordinate of the midpoint. So that's equal to, if you take the two x's, x sub 1 and x sub 2, and you add them together and divide it by 2, that'll give us the middle point of our 2 segments, or for our 2 points, and that would be our x coordinates. So x sub 1 plus x sub 2 divided by 2. That would represent your x coordinate of your midpoint. To get the y coordinate of the midpoint, you do the same thing with the y coordinates. You have your y sub 1 plus y sub 2 and divided by 2. So that's the midpoint formula right there. In example 3, we're going to find the midpoint of the segment given. So we have our first point at negative 1, 0, and our second point at 4, 2. So let's label our coordinates, x sub 1, y sub 1 as our first point, and then x sub 2, y sub 2 as our second point. So then, if we're trying to find the midpoint formula, I'm going to write down x sub m, comma, y sub m, Knowing that we have to find the x coordinate of the midpoint and the y coordinate of the midpoint, our final answer should be an actual ordered pair. So to find the midpoint, we take our x's and we add them together. So we have negative 1 plus 4, which are our two x coordinates, negative 1 and 4. Add them together, divided by 2. Our y coordinates, y sub 1, which is 0, plus y sub 2, which is 2. Add those two together and divide it by 2. So now you simplify. Look at your answer is going to be in an ordered pair. You have your parentheses on the outside, and then you have your comma in the middle to separate your x coordinate and your y coordinate. So if you simplify each part, you get 3 halves, comma, 2 over 2, And if you simplify further, your final answer would be your x sub m and your y sub m is equal to 3 over 2 comma 1. So your midpoint between these 2 points would occur at 3/2 comma 1.